All right, here we go with our 2.4 notes on average rate of change of a function. I want to start off with this warm up. Suppose you're driving in your car on the highway. The graph below shows the total distance traveled in miles each hour after 12 o'clock noon. Find the average speed of the car from 1 p.m. to 4 p.m. So, in order to find the average speed, we first have to know how far we've traveled at each of the times at 1 p.m. and 4 p.m. Taking a look at our graph here, we can see that, well, 0 hours after 12 noon, that's 12 noon. 1 hour after is 1 p.m. So this is what we're looking at. At 1 p.m., we have traveled, if this is 100, halfway is 50. So at 1 p.m., we've traveled 50 miles. And 4 hours after 12 noon, or 4 p.m., we've traveled a total of 200 miles. So to find the total distance traveled between 1 and 4 p.m., we can find the difference between 250, which gives us the 150. In order to find how much time has passed between 1 and 4 p.m., we can always find the difference between those times. So at 4 p.m., we're 4 hours after. At 1 p.m., we're 1 hour after. So the total time passed is 3 hours. So in order to find the speed, we know that speed is a unit distance per unit time. So speed is distance over time. In this example, we're talking about miles over hours, or miles per hour. That's going to be our speed. So the total distance traveled from 1 to 4 p.m. is the change in y. That's our 150 miles. Our change in x, or our change in time, is going to be from 1 to 4, or that 3 hours. So in order to find our speed, we divide these two. So 150 miles over 3 hours gives us 50 miles per hour. And so that is our average speed over the time interval 1 p.m. to 4 p.m. So that brings us to average rate of change. We know that speed is a rate of change. So in general, let's talk about what an average rate of change is. The average rate of change of the function y equals f of x So we're going to say y is a function of x. And we're going to say the average rate of change on the interval. And since we know interval notation, let's go ahead and put that. We're going to say the closed interval from a to b. Okay, so a and b are x values, and we can see that here on the graph. The x values, a to b. So between here and including the endpoints a and b. Okay, we're saying that that average rate of change is given by the change in y over the change in x. Or in other words, using function notation, we're going to say the change in y is the difference in our y values. So if we're looking at a and b, we're going to take that endpoint b and that starting point a. So we're going to take our function values, f of b and f of a, and we're going to take the difference. That's how we find the change in y. So we have f of b minus f of a over the change in x. So our endpoint minus our initial point. So b minus a. So change in y over change in x. If you were to look at this graph, we can see that it's the change in y, or this vertical distance, over this horizontal distance, change in x. Where have we seen this before? Our change in y over change in x. You might see this as familiar. This is similar to the slope of a linear function. So if you remember the slope of a linear function, we find our slope as the change in y over change in x. So let's use that to find the average rate of change over the given intervals. So here I have three functions. I have f of x, h of x, and g of x. Let's find the average rate of change over the set intervals here. This first one here, we're finding the average rate of change from -2 to 4. So plug it into our formula, we need f of b and f of a. So let's go ahead and find those first. So f of b is the function value at our endpoint, which is 4. So we're finding f of 4. Well, f of 4 take a look back at the function f. We have x squared minus 5x, so we have 4 squared minus 5 times 4. Well, 4 squared is 16, minus 5 times 4 is 20, so 16 minus 20 gives us that negative 4. So that's f of b. F of a is the function value at our initial point, or negative 2. So f of negative 2 is, well, we have negative 2 squared minus 5 times negative 2. Well, negative 2 squared, is 4 minus negative 10. So 4 minus negative 10 gives us a positive 14. And now we can plug it into our average rate of change. We have f of b, which is at negative 4, minus f of a, which is 14, over b minus a. So b is 4 and a is negative 2. So 4 minus negative 2. We can simplify this fraction. We have negative 4 minus 14 is negative 18, over 4 minus negative 2 gives us 6. And we know negative 18 divided by 6 is negative 3. So the average rate of change over the interval from negative 2 to 4 is negative 3. Let's try another. Here we're looking at h of x, and I've given you the graph. So we need to find the average rate of change from 1 to 3. So at x equals 3, let's take a look at the function value, or h of 3. Looks like it crosses the x-axis here, so this is an x-intercept. The function value at 1, or h of 1, looks like right here. So this point we could say is 1, 2. So then h of b is h of 3 is 0. And why don't I go ahead and write that? So h of 3 minus h of 1 over b minus a, 3 minus 1. Okay, so h of 3 is 0, minus h of 1 is 2. We find that from the graph. Those are our function values at 3 and 1. And then 3 minus 1, well, that's 2. 0 minus 2 is negative 2. And we know negative 2 over 2 is negative 1. So the average rate of change in h from 1 to 3 is negative 1. Last but not least, we've got a table of values. Let's find the average rate of change here from 1 to 5. So we can take g of 5 minus g of 1, that's our initial point, over 5 minus 1. Plugging in those values, well, g of 5 we know is 7 from our table of values, minus g of 1, that's 4, over 5 minus 1, well, 5 minus 1 is 4. And then simplifying, we have 7 minus 4 is 3. So we get the average rate of change is 3/4. All right, we're going to get a lot of practice on this, so study up and we'll see you tomorrow in class. Have a great day.